Hello and welcome to the first video of week 2. So this is the first full week where we're going to have multiple tutorial files to complete and multiple lab files. A lot of the tutorials we're working on now are pretty basic, so we should go by fast for you. Later in the semester we'll have less files to work on because they'll be more complicated or more detailed. So I'm looking at the week 2 course content folder. Drilling and tapping is where we're going to start because it's one of the easier areas to kind of understand and get used to. Again, reference videos should be watched already, and we're going to start with 1-1 drill through tutorial. Okay. Inside of this folder, we have the PDF print, we have a detailed written instructions, and then we have a Mastercam file template. The detailed instructions are from a couple of years ago. They're a little outdated. I'm not going to have a lot of time to redo all of them, so some of the stuff in there might be in different spots, or it may have a little bit different look to it, but the basic function is the same. So just keep that in mind. If something looks a little bit different than it does in the PDF, then just don't let that mess you up too badly, because it's still going to be in the same general area, and I'll point that stuff out as we come across it. So I already have mine downloaded. I'm in the tutorials. Let me just go ahead and show you the write-up first. So this is the drill through tutorial that we're going to be looking at. Okay, again, a couple years old. I apologize for that. We also have a blueprint showing the dimensions of the area we're working with the print we're working with. And then we're also going to have a Mastercam template file. And again, I already have all this downloaded, so you want to do the same. Download all these files, make sure you know where they are, and have the print and the instruction sheet open. So I'm now going to go into Mastercam, and I'm going to open the template file that I downloaded. File open. I'm going to find my file structure. And I'm kind of showing you this just because I think it's good for you guys to get used to the basic steps of how to start something. So here we go. Again, I have my week 2 set up like this. Oop, that is actually the wrong folder. Oh, that's right. It's on my desktop. And while we're actually looking at this, let's talk about the opening area here. So you'll notice that in the bottom right hand corner there's a filter. Right now it says all Mastercam files. If you are looking for a SolidWorks folder that you're going to open instead to import, you would need to change this filter to all files, and then you'll see everything in there. If you don't do this, you're only going to see your Mastercam educational files, and you will not be able to select it to open. So all Mastercam files is my filter. This tutorial is right here, 1-1 DT drill through. I'm going to select that and hit open. Give it a second to load. Perfect. So this file has already been started for us. I'm going to hit F9 to turn off the axes and the home position just so we can take a look at the file first. Okay. This is a SolidWorks model that was put in place previously and pre-set up for us. You'll see that we have the stick mill 3-axis selected for the post. We already renamed this to Op10. G54 is the work offset system. So when you are establishing your planes on your part, G54 is your first coordinate system G number. As you create different planes and you machine different sides of the part, your operation number will go up, so it'll be Op20 for example, and then your work coordinate system number would go up, so it'll be G55, G56, G57, and that's just the designator for that specific home position in your machine that you've touched off and qualified. I will go to the solids tab in the bottom left just to kind of show you that here are our solids. There are a few things turned off right now. So if you actually go to levels, you'll see we have a lot of different levels in here. And there's actually a lot of different pre-built geometry. So if I turn all this stuff on, you can kind of see fixtures set up. This is more advanced, obviously, but we will be doing this in the future. For right now, all we are concerned with is the Op10 generation stuff. So I'll turn the vise on just for fun, and then I don't want to confuse it. I don't want to confuse ourselves. So let's just keep the part for now, and maybe we'll come back and look at some of those other details later. Now inside of toolpaths, we actually have a few things set up already. So we have a facing command, we have a facing machine operation happening, or toolpath happening already to clean the top of the stock. Since we already have this, I'd like to introduce you to backplotting before we continue and start drilling the holes. So backplot is this area in the middle. You see this icon with like the blue wavy lines in it. When you click on backplot, it operates much like a video player. So we have some speeds, we can turn on and off tools, and then we can actually watch the toolpath. So I'm going to bring the slider way down. I'm going to hit, well, a little bit faster. I'm going to hit play, and we can actually watch the cut happen on the part. Now there's no stock or anything turned on right now, so all we're looking at is the tool in contact with the part, and it's machining off whatever amount of stock is left on the top of the part that's above 0. Okay, basic introduction. We'll be doing stuff like that later on too. While we're talking about that, so let's check out our planes. If we highlight our Op10 plane, and again, we'll be creating these ourselves later on, so don't get hung up on them too much. But what I do want to point out is when I say 0 is the top of the part, this is what I mean. So the work coordinate system is set up in the bottom left-hand corner, and Z0 is on the top of the part, right there. Okay, this is going to be consistent through most of the files that we do. Bottom left-hand corner is standard, and then the top of the part is Z0. That is driven by the part in the geometry of the part itself and the print. So you kind of have to take those two things into account when you're deciding where your offset should be. Okay, so again, we'll be talking about some more setup stuff later on. I want to get you an introduction to the actual machining parts of the program, and then we'll talk more about setup later on in the class, maybe even later on this week. It depends on how much time it takes us to get through these things. Okay, so we are going to, let's walk through this first here. So again, this is the PDF that you can download off of the week 2 folder. Here's the print again. And so here's an overview of what we're going to be doing. So the basic tolerance for drilled holes is +6 -0, which is a standard tolerance for drills. So that qualifies what actual operation we're going to use to create these holes. So the nominal size is 332, which is a clearance hole for 5/16, 10 thousandths clearance per side. So basically, there's not a lot of stuff we need to do as far as work holding to make sure that we keep these tolerances tight. They're not locating, they're just clearance. So we're just going to basically plow a couple of drill holes through this thing and be done. So we've already downloaded the file. We've opened it in Mastercam. And again, this file already has the stock, some toolpath groups, the work coordinate systems for Op10 and Op20, and the facing toolpaths for Op10 and Op20. So some of this stuff is all set up, was done before we got to it, and then we'll come back to some of this stuff later. So what we're going to actually do in this file is we're going to spot drill, we're going to drill, and then we're going to verify that the part features were created successfully. That's all we're going to do. We're not going to deal with any of the milling features today. So spot drilling is a method of drilling that is more rigid than a standard twist drill. A spot drill tends to be short. It's solid carbide, and you choke it up in the chuck as high as you can so that you have very little wobble when you're drilling. And that's to this point, step one, rigid start point, which stops the drill from walking. So meaning if you have such a long drill, when you contact the part, the drill is going to want to drift off like this. A spot drill will not do that. We will use a depth calculator to figure out what the depth of the spot drill should be. We'll see that in a minute. And now we're going to move on to starting tool paths. So I'm going to walk through this while reading it on my second screen. When you go to perform this work yourself, you'll want to read through this tutorial and follow it line by line. It's pretty quick. Okay, so we're going to start by ensuring that the red flag, which is this red insert thing, is in the right spot. So whatever toolpath you start is going to be inserted where this red flag is. So we want to add this drilling operation inside of the op10 tree. So that's where we're going to start. So we're making sure that flag is there. We're going to navigate to the toolpaths tab if you haven't already, and we're going to go ahead and select drill. Okay, so again, let's read the tooltip. Select one or more entities to add or remove from the feature list. What that means is it's asking us to select the holes with which we are going to be drilling. So we are going to set the graphics view to isometric, which basically means you can see it in 3D on its side. It's just a little bit easier to grab points that way. If you're looking at it straight down, it's kind of hard to tell where you're selecting your points. Now what we want to do is we want to highlight all 4 holes, and we're going to drill all 4 at once. So I'm going to use my middle mouse button and scroll into each hole and make sure I get the center of that hole. I don't want to snap on a quadrant. You can kind of see the different snap point there. We want the middle one. It looks like a hole with a plus in the middle of it. That's what we want to click. And then you get the asterisk in the middle of the hole when you get the right selection. So that's 1, 2, 3, and 4. So we have 4 center hole locations set up for our drilling commands. We are now going to click OK, and when we do that, it's going to enter into the drilling toolpaths dialog box. Okay, all of these dialog boxes are going to look very similar. However, there will be different inputs depending on which command you're running. So to start, we're going to work from the top down. We need to select our tool. Okay, what we're looking for is we're looking for a 1/2 inch spot drill. Our library may look a little bit different from the stick mill library. We're going to have more options here because we don't have our tool carousel set up. In order to find the proper spot drill, that we're actually in good shape, because when you first open this up, the spot drills are right on top here. So I'm going to go and find a 1/2 inch spot drill. For us, it is tool number 24, and I'm going to click OK. Now in the comment box, we're going to describe what the operation is actually doing. So in our case, we're going to spot 4x holes to a size of 0.362 diameter. Now this comment will be posted to the machine code when you generate it. It'll be after an asterisk, which basically tells the machine to ignore anything after that, and you can have notes in here for the operators so they can read this. Okay. Speeds and feeds come in attached to the tool. They may or may not be correct. We're not going to touch on feeds or speeds today, but just keep in mind that the tools do have some values associated with them, but you always want to check them. You don't want to use these as gospel. They may not be correct. So working our way down the list, the next one is holder. We're going to ignore that for now. It's not important to look at that. We're also going to skip stock, and we're going to go right to cut parameters. So inside of cut parameters, we have to pick our cycle. So there are a couple different options. We have peck drill, chip break, tapping, drill counter bore. Right now we are going to use drill, and we are going to set a dwell time of 0.300 according to our PDF. Reason being is the dwell, when you select a dwell amount, it puts a G81 code in there, which basically allows the drill to sit in the bottom of the hole for a second before it removes itself, which is good for ensuring that you actually have a fully formed hole. If you just go in and out very quickly without dwelling, you have a chance of having an oblong hole or not having a fully shaped hole. So adding a dwell just makes it sit in there for a little bit. Peck clearance and retract amount are not important. They're turned on for us, and they show turned off in the cut parameters in the PDFs, but don't let that bother you. So we're going to skip by tool axis control, and we're going to enter linking parameters. Linking parameters is the most important area of the toolpaths dialog box, in my opinion. It has a lot of information in it, and it doesn't matter what you're doing, milling or drilling, this is an important area. So clearance is always going to be 2 inches, and it's always going to be absolute. Your clearance is basically the point, the Z point, the point in space in your Z, where when the tool rapids over, it's going to stay at 2 inches. So it's always clear of the part. You have no chance of smashing into something unless it's 2 inches above your Z0. So it's always going to be a clearance of absolute 2, except for unless there's some kind of special mitigating circumstance. Okay, we're always going to use clearance at the start and end of the operation. We don't want to keep retracting to 2 every time, so just the start and the end. Retract is going to be 0.1 absolute. So the retract value of the drill means that it's going to cut the depth of the hole. It's going to come out to the top of the hole, and that's going to retract 100 thousandths before it makes another move to the clearance diameter. Okay. Our top of stock is going to be 0. We want that to also be absolute, which basically what this means is that all the stock has been removed from the top, and we are starting our drilling right at Z0, right on top of the part. Now our depth is where we have to calculate or use the calculator to figure out how deep the spot drill has to go in order to get that 382 diameter that we want. So for this instance, we are going to click on the calculator, and the depth calculator shows up. It reads what the tool diameter is, and it also reads the angle. So it's going to calculate the hypotenuse for us and tell us how deep we have to go to get to 382. Okay, so this finished diameter here, or 362, I apologize. Our finished diameter wants it to be 362, which is going to give us that slightly chamfered hole. You type in 362 and hit tab, and you'll notice that our depth changes to negative 0.181. So that's how deep the spot drill has to go in order to create a hole that is a spot that is 0.362 diameter. Now we want to overwrite this depth. We don't want to keep adding it by accident, because it'll keep adding 181 together if you do this multiple times. So our final depth should be negative 0.181. I'm going to override what's there and click OK. So now you see that our depth is 0.181. We do not want that to be incremental, though. We want that to be absolute. So again, that's based on 0. Oh, and we cleared it out. So I'm going to retype that in. Negative 0.18. What did I say? 181? 181. That's correct. And again, this is negative because the top of the part is 0 and we are plunging into it. So when you see a negative number, the way we set this up is you always want to assume that you're actually cutting material when you do a negative number. So this should cue you when you see this that, okay, we're actually making a cut. That's the last thing we're going to look at in here for now. So we're going to go ahead and click Apply and OK. And we should see 4 hole patterns generate. And the yellow lines are movements, are rapid movements. So this is our clearance. So you see our clearance of 2. It comes down, and then when it turns blue, that's actually where our retract amount is. And what we're going to do now is watch a back plot of the command that we just finished. So the back plot again is the blue wavy command, or the blue wavy button up on top here. It will play whatever toolpath you have selected. So if we only want to see toolpath number 2 run, we need to select it and get the green checkbox over the yellow folder. That's how we know that that's the one that's going to play. So now that we have ensured that we have the right operations selected for backplot or for preview, I'm going to click on the backplot button. You're going to see that our center drill shows up. And there are a few things that we want to do while we're watching the backplot. Okay, so the first thing that we want to confirm, and that's sometimes easier in isometric view here, is we want to make sure that the tools are in the right location. So we can kind of let it run. You can slow it down if you have to. We can move around. I want to make sure that we're on center. Everything makes sense. The diameter looks good just looking at it. If we slow it way down, you can kind of get a feel for the depth. So if I zoom in here, you can kind of see that it matches the shape of the geometry there, which is good. And we can also run this command and look at it from the right hand side and make sure that, you know, our depth looks, again, same thing. We can scroll in here and kind of watch it. One other thing we could actually do while this is running is go into View and then change it to Wireframe, and we can actually watch the tooltip penetrate the part. I went a little too fast. There you go. So this is, you can see it's moving to location. If I go back to the right hand view and have a little bit of patience, we can let that sit and we can see that go. I'm going to change it back to outline shaded here. Outline shaded, there we go. Good. So I am very happy with those 4 spot drills. One thing of note that you can look at while we're backplotting is there are a couple of keyboard shortcuts in here, S and B. So if you want to skip to the next, movement, you can continue hitting S, or you can also hit the B button, and that actually sends you back through each command. So S is kind of a way of skipping through, and then back, you can go back to previous. So you may want to remember that. Now, the other thing too that you may want to think about, and I haven't touched on, is you can see in the bottom left hand corner X, Y, and Z's. We can actually, I'm sorry, in the bottom left hand corner, that's the actual position of the tool as it moves. So if you watch that, you can actually see the distance. And if you want to make sure that we have the right one, you can skip ahead to the end of the cut, and you see that Z minus 0.181, right? So that's our depth that we inputted in. And then you can also see the X and Y coordinates if you want to confirm on the print that those are correct. So just a couple of things to keep in mind. We are now on to the drill through toolpath, which is page number 16 in the PDF. Now we have the spot drill over here. We already picked our 4 points, so we can kind of cheat a little bit. We can actually copy this toolpath and not have to repick the geometry again, which is, or I mean, you can repick it too, but sometimes it's just easier to copy an existing. So that's, again, page 17 says it's identical to the spot drill. So we will go ahead and Oh, actually, it doesn't tell you about that, does it? Well, let's copy it. Well, we'll copy this. So you see drill counter bore, it's the same command for drilling. And let's say we don't want to waste our time picking these 4 points again. You can actually right click on drill counter bore. You can hit copy. I'm gonna right click next to the insert flag, and I'm gonna hit paste. So now we have 2 of those drill counter bore the 2 of those spot drills. And now let's go ahead and just modify number 3. I'm going to click the plus button next to it. I'm going to confirm that there are still 4 holes picked. So there's the 4 holes that we just picked before for spot drilling. And now I'm going to go into parameters. Okay. I'm going to go back up to toolpath type, and now we'll start from scratch basically and re-choose our details. So the point geometry stayed the same. Drill is still the same command. Now we're going to go to tool, and we got to switch to our drill. So the drill size is a letter Q, which is 0.332. We're going to go into select library tool. Now we can use our filter, or we can scroll. So this is relatively easy, so I'm just going to scroll down looking at my diameter here until I find 332, and that should be a letter Q. So it's tool number 141 in our library. And click OK. Now we need to change our spot drill comment to 4x, so we're going to 4 times drill through. And then we can put a final Z value in here if we need to, which we'll know later on once we fill out our linking parameters fully. So one thing we did do is when we copied this, the feed rates and everything stayed the same. And so let's change that. So we'll match the PDF. So the feed rate of 0.45 is good. This is inches per minute. Spindle speed 1146. Feed per tooth, I believe that's what that is, 0.002. And surface feet per minute, 150. We'll talk more about this later. Oh, and actually this feed rate changes based off of that anyways. I think it updated itself based off of the tool after we started typing stuff. So that's fine. We have the note in there. So now we can slide on down past holder. We don't do anything with that. And stock, same deal. So now cut parameters. This one we're going to do a peck drill. Now a peck drill is a cycle that you use when you want to evacuate chips on a deeper hole, especially on ones that aren't drilled through. So what's going to happen is we're going to specify a depth of cut increment before so it'll go 100,000. Let's say we specify 100 thousandths. After 100, it's going to retract back up and then come back in and plunge down. So it's gonna basically chip away or peck away at the material. So normally the peck drill cycle is 3/4 of the diameter of the drill, and we can do math in these yellow boxes. So our first peck, so this is a little bit different. So first and subsequent can be the same. We don't need to have a larger number for either. So if we do 0.332, which is the size of the drill, times 0.75 or 75%, we get a value of 249. So we're going to go ahead and put that in first and subsequent. And then everything else we don't need to worry about. So I'm going to put peck clearance at 0, retract at 0, and we'll leave dwell and all this alone. These are add-ons since the last time we updated the PDF. So as long as you have 249 for first and subsequent, we're good. And then it goes in a little bit more detail in the PDF. You can read through that and see what that says. I'm not going to read the whole thing to you right now. So now we go back to linking parameters. Next one down. And again, this all got copied over from the previous command. So the 2-inch clearance absolute is still in there, which is great. The retract is still 0.1, which is great. Stock is still 0 absolute, which is great. Now we need to modify our depth. So negative 0.181 was the spot drill. Now we're going to change that. So one good thing about having a solid is that we can use the geometry instead of typing. So if I click on depth, it asks me to select a point. I'm going to use the middle mouse button to rotate to the bottom of the part. And I'm going to select the bottom of this chamfer, or the top, depending on how you want to describe it, the highest point or the lowest point. Now that tells me that my depth is negative 0.71. Now this is not good enough because that only means that the tool tip will get to the bottom of, and we'll go to negative 0.71. We need to break through that amount in order to make sure we get a fully formed hole at the bottom. The way we are going to do that in this instance is by using tip comp, which is the next one down. Inside of tip comp, we're going to turn that on. We're going to select a breakthrough amount of 100 thousandths. So it's going to break through at least 100 plus this tip length. Okay, so that's going to end up our final depth. This is calculated based off the tool, and then this is a user input. Okay. Again, you can read the PDFs for some more details. So I'm going to hit apply and OK. Because we copied the toolpath and changed some values, you'll notice that there's now a red X on the toolpath in the tree. That means it needs to be regenerated. It's dirty. Something's been changed and it needs to recalculate values. And you do that by clicking on it and then clicking OK in this box. So there we go. Now we're going to backplot this, and we're going to pay special attention to our last Z value on one of the holes, because then we will go back into parameters and we will actually fill that in the Z minus in the comment. So let's go ahead and backplot this. I'm going to hit the S key to skip to the cut there. Here's our peck drill. You see that? So it's pecking all the way through. I'm going to pause it now and just hit the S key until it gets to the bottom. Go back. So that's our lowest point. So it looks like our final Z depth is 0.9097, which matches up with the PDF. So while we're thinking about it, I'm going to go back into the peck drill parameters, go back to the tool note, and put that value in as our Z minus final depth, so 0.9097. And that is just a good reference for the operator to have. And now that we've done that, we're going to go ahead and backplot it again. We will look at the solid verify in a second here. But I just want to backplot it and ensure that I don't see anything funky happening. We'll go ahead and speed it up because we already know that we've done this correctly, really. Let that run. You can always skip ahead if you want to. Excellent. So that backplot is correct. I'm going to go ahead and save this. I have not saved it yet. We probably should have saved it earlier than this. Generally, I will say to save your file after every operation that you do, because the system does crash sometimes and you will lose things. So, you know, definitely make sure you keep saving. So, the PDF just talks about going back there and checking that out. So now we're going to check out Solid Verify. So backplotting happens inside of the Mastercam drawing window. Solid Verify, which is the button next to it, actually opens a new window and will actually allow you to see it visually occur with the solid. So in this case, the part is red, which is terrible. I don't know if I can change that in here. There must be somewhere to change it. Again, because red is the color of crashes, so you really do not want that to be red. I don't understand why it's showing up like that. Gray is really... I forget how to change the color in Solid Verify. I will get back to you on that, but this is not good. Just keep that in mind. So, oh, and I should mention too, so I only have that one green checkbox selected. If I wanted to verify all of it, I can highlight them each individually by holding Shift and selecting, or I can just select the entire Op10 toolpath group. That picks all three underneath that, and then that's basically that's pretty much how I want to verify it. So I want to verify all three of these at once. Because we have different tools, I want the color loop to be turned on, and that basically just means that every tool is going to have its own color when it runs, and you'll see what I mean when we let it go. So now I'm going to hit the play button, and depending on your computer, it may or may not look really good or really bad. So my computer's decent, so it works pretty good. You'll see yellow was the face mill, blue was the spot drill, and purple was the drill. And again, you know, if we had a crash here, it'd be hard to see because the part itself is red. And there is a little bit of a confusing point. So these red marks here are not actually part of the simulation. They're tick marks from the WCS. So keep that in mind when you're looking at it. That's not leftover material. Those are just tick marks. So good. So I'm really happy with this part. I'm going to close the Solid Verify. And that concludes this tutorial. So go ahead and save this file. And just for clarity's sake, what you would do now is go to Blackboard. Go back to the main Week 2 folder and find the blue link for the Week 2 1-1 drill through tutorial, and go ahead and upload this file. I'll be making the video for the tap through next, and I will see you there. Thank you for watching.